A very good morning, afternoon, and evening to everyone, those who have joined once again. Myself, Aman Jain, and I work as a solution consultant for Bricsys for the APAC region. I completed my graduation in mechanical engineering and I'm handling the manufacturing portfolio at Bricsys. In this session, we will unveil sheet metal design in BricsCAD and how we can easily migrate to BricsCAD Mechanical from a traditional 3D MCAD tool. From concept to fabrication, we will also try to discover BricsCAD's tools and the workflows that could essentially speed up your entire sheet metal design tasks. So sit back, relax, and enjoy in this deep dive session with me on BricsCAD. So just to introduce Bricsys as an organization, we are provider of cost-effective modern CAD, building information modeling, mechanical design, and collaboration products brought to the market under the BricsCAD and Bricsys 24/7 brands. We are now a part of a large conglomerate called Hexagon AB, which is almost a 5.2 billion euros revenue technology group with about 500,000 active users in over 110 countries. That shows the acceptance BricsCAD is receiving worldwide. We as a company are headquartered in Belgium with about 300 plus employees in 8 different global offices and a very strong extensive partner network system across the countries that we're serving in. So, before demonstrating BricsCAD's offerings to you all today, I would like to discuss a bit more on the challenges that a particular customer had or could be facing before switching to BricsCAD. Let us discuss them one by one. We all know that transitioning to a newer CAD technology, like any specialized 3D MCAD tools, require companies to evaluate whether they need to hire new staff with expertise or train their existing staff on top of these advanced tools. Both of these processes requires a company to invest in terms of time and cost both, which at times could be a more costlier affair if the implementation does not go the way it was intended to. This transition period could also lead to temporary productivity losses as the workforce adapts to new tools and processes. Another concern that bothers most of them is the compatibility between their existing CAD and the new tool sets that they are trying to adopt. How easy it is to migrate is one of the questions that's asked by many of these organizations. With BricsCAD offering everything in native DWG format, we aim to solve these challenges by providing the industries a single platform for all their 2D and 3D workflows with a similar interface, all at an extremely robust cost. So yes, a software is capable enough to do a lot of things, but the real question is, do you really need it? A typical CAD workflow is what we see on the current slide. We start with the component design. These components are then used to create assemblies, which is at the heart of any CAD workflow. The assembly may require you to model certain parts using surfaces or sheet metal. And once the sheet metal design and the assemblies are ready, we go to the production drawings. Presentation and animation, if not mandatory, but remains an essential part for us to be able to create our design technical manuals and so on. Now, this entire workflow is very robustly supported by the BricsCAD Mechanical solution we have as an offering. And today in particular, we'll be looking at the sheet metal design module and how it helps users to improve or rather collaborate or coexist with their existing CAD solutions that they may be using. This slide illustrates the computer-aided sheet metal fabrication workflow and highlights how BricsCAD is integrated within this workflow. The process is divided into several categories, several key phases, that is CAD for manufacturing, for quoting, planning, programming, and production. BricsCAD plays a very vital role in the preparation and the production stages. BricsCAD can be used to create and document the as design or the nominal geometry of the sheet metal parts. This involves creating detailed CAD models and ensuring that all components are correctly assembled according to the design specifications. Within BricsCAD, the bend and unfold operations are validated to ensure that the design parts can be manufactured accordingly. This step is essential for confirming that the parts will behave as expected during the bending and the unfolding processes. And then once the geometry is validated, it feeds into the quoting phase where the validated geometry is used to calculate the cost, create quotations, negotiate price with the customers, and so on. The validated data from BricsCAD could also be critical for the planning phase, feeding into capacity planning, material planning, and scheduling. This ensures that the correct bill of materials and work are accounted for and that the project is scheduled effectively. Subsequently, this information can also be used for the nesting processes where parts are optimized for material usage. This feeds into the programming phase where the tool parts are sequenced for manufacturing. Finally, the production phase involves the machine tool execution of the NC programs generated earlier while with ongoing progress inspection. The feedback loop ensures that any such issues, defects, used time, and material are recorded and managed, optimizing the overall manufacturing process. In summary, BricsCAD is quite integral at the early stages of sheet metal fabrication workflow, particularly in preparing and validating the design geometry, which ensures accuracy and efficiency throughout the subsequent manufacturing stages. The next slide showcases some of the key sheet metal modeling features that are available in the traditional 3D MCAD tools. So we start off with something called as base flanges, which forms the base of the geometry of the entire sheet metal body that we are going to start with. Then comes the edge flanges, miter flanges, the reliefs that we have, the forming tools, flattening process, bends, junctions, T-junctions, converting an existing solid to a sheet metal body, sheet metal parametrics, and also some specific features such as closed corners and zero bends. With these features, a user can completely model their sheet metal bodies within the BricsCAD environment as compared against the traditional 3D MCAD tools. So just as to say, all these features that we see on the left-hand side are all available in the BricsCAD Mechanical solution. And then, of course, since BricsCAD is known for its AI-based features, we do have AI-based features in the sheet metal module of the mechanical software. There's something called as associative unfolding, repair bends, smart split propagates, design intent recognition, and also automatic feature recognition, which are all available within BricsCAD. We'll have a look at some of these features in the demonstration that we'll be having post these slides. So here we start with the demonstration now. And we'll start with BricsCAD V24, which is the latest version of the software. I'm using the ultimate version of the software, and hence I get access to all the modules present within BricsCAD. It's the only software probably in the world today that allows us to do BIM modeling as well as mechanical modeling within the same environment. Hence, integration and collaboration becomes very smooth. Now with this, we start off with a new drawing. And today we'll be making a sheet metal enclosure. So for that, we'll be having two processes that I'll show within the demonstration today. One is where we create the sheet metal from scratch within the BricsCAD environment. Another is wherein a sheet metal body would already be available with us and how we can bring it inside BricsCAD to be able to convert it and use it further inside this environment. So here I'm using the 2D drafting tools of BricsCAD just by creating a plain rectangle or square rather, because it's 700 by 700. in dimensions. And I'm just trying to place it at the center. Since BricsCAD does not involve creation of plane geometries at all, it does not really matter on which plane we are trying to create our geometries from. So the initial design intent, which we need to keep in mind for our traditional MCAD tools, is not the thing that we need to do in BricsCAD. We can simply start with any of the planes that we'd want to work in. And as simple as this, we are able to create this base flange. So if you see, I just use the base flange command to be able to create a flange out of the rectangle or the square that we had created. And we have all those parameters that we can work with regarding folding and unfolding of the sheet metal body that we have in place, including K factors, bend reliefs, bend radiuses, so on and so forth. The next part would be creation of the edge flanges. And this time around, we'll select the edges in a very smart way. So this is one of the smartest way of selecting all the edges across instead of selecting it manually. And we'll select create edge flange from outside. There are two possibilities of creating an edge flange. One is from outside and one is within the flange itself. I mean, bending it internally, depending upon the type of bending process that we'll be following during our fabrication stage. And as you can see, within a fraction of a second, we were able to create these flanges, but also the corner reliefs and the junctions are automatically created as well. This corner reliefs we can change or modify depending upon the type of corner relief that we would want to use for our body. Of course, even in terms of the junctions, we can change the type of junctions, the junction mating that we'll be having at the end of this modeling process. So we'll try to create one more flange body. Now this is actually the door of the sheet metal enclosure that we are trying to create or model. And hence we'll be creating one more outside flange with a distance of 10 mm and 90-degree bend angle. Now with this, if we see in the left-hand side, we see the corner reliefs and the miter flanges have automatically been created. The miter reliefs have automatically been created. At the same time, if I want to change the type of the bend relief that I'm getting over here, because essentially for a sheet metal enclosure, we need to make sure it's as packed as possible so as to avoid leakages of any kind. So let's say if I select all these bend reliefs and from rectangle we make it smooth, we see the gaps have been closed to a minimalistic value. And of course, these values could be changed at a later stage as well. This is currently using the global value that had been defined along with the sheet metal parameters when we created the base. But this could be an absolute value, and we can change those values manually as well. So the next part would be creation of vents and some keyholes for us to be able to place the switches. So we'll be placing the switches as well. So since this would act like a control panel, we'll be having our red light switches as well as the green light switches and the lock for the door to open, as well as the vents for the air to circumvent. Now, as you can see, the wonderful part about BricsCAD is it doesn't, let's say, differentiate between the 2D environment and the 3D environment. I can use commands as simple as BricsCAD commands through a command line, even for my 2D geometries and the 3D geometries that I create. There's a library, a 3D library and a 2D library as well that comes along with the installation that we do. And here I'm taking a hole. This is actually a 3D parametric hole that's available within the library. And I'm just placing it, snapping it on the top of lines that I've just created. And very simply, I can then mirror these lines, just change the diameter as per the diameter of the switches that I'm going to insert. As I said, these are all parametric features that are available within the libraries that you get. And of course, we can create our own custom libraries as well. We can simply add the components to this and have our own custom library created. So here I'm just mirroring this particular hole that we have created. And I'll just mirror those two holes as well. So we have about 4 switches. So we'll mirror this again based on the horizontal line that we have. So let us mirror this. two holes that we have created. Select this one as well, and use the center line as a mirror line for us to be able to create this one. Now you may seem to feel that this is all in 2D because we are in the 2D wireframe representation, but this essentially is in 3D, and we'll change the representation to a modeling perspective or any other perspective that shows us a 3D model. We'll actually be able to see that these are all actual holes, right? So here I'm placing to add one more hole. So which is for the lock, right? Where the lock would be placed in. Let's say this would be at a distance of around 140. Now, this is smart placement of the holes as well. So ideally, I'm able to place this in conjunction with the holes that I had already created, and I can add distances based on their positions. So this relatively becomes easier for me rather than creating sketch geometries for each and every one, each and every feature that we add, right? Now, this is a slot. Not sure if you are able to see the slot representation because it's in red. So we'll rotate the slot by 90 degrees, and let's say from the vertical flange or the horizontal one, it's at a distance of 100, and from this, it's at a distance of 50. And we'll then array it so that we get multiple instances of this slots. Now, these slots would act like vents for our enclosure. That's the door. You just select this and have an associative array created for this particular slot that we have, right? Simply adding the numbers. So let's say for the columns, we have 20 numbers and the distances is 31.5. And then the rows, number of rows, we can increase to 4 or 5 depending upon the designs that you have in place. So let's say for this one, I'm just increasing it to 4, keeping the distances between the slots same. Just hit enter, and that's there. So I have my holes placed, I have the slots placed as well. And when I switch the perspective to 3D, we see that, okay, these are actually hole representations and slot representations onto the sheet metal body. And when I switch off this layer, it's actually subtracted the material out of our base flange. Okay. And BricsCAD kind of is able to recognize these features as the sheet metal features in general. And I just save this file before we move on to the next step. So this is, as I said, is the door DWG. Everything in BricsCAD is DWG, right? So that is kind of the USP of the solution offerings that we have. Let's say if I want to make it backwards compatible, share it with someone who's not using BricsCAD V24, I can do that. You cannot do that with any other traditional MCAD tool because they have their own proprietary extensions. So here's the unfolding pattern of the geometry that we created. And I can save this 2D geometry as a DXF file. So it's kind of a one-click DXF. I'm able to create DXFs. So as we looked in the process where we need an input from the CAD software to the machining software, this is the one that's most widely used. This can be used in most of the CAM softwares worldwide. And then the machining codes could be generated on top of this. So as you can see, the bend lines, the representations, the reliefs have automatically been created for the DXFs that we have in place. Let's save this. All right. So this is part one of our modeling process, wherein we were able to create this entirely from scratch using BricsCAD's own functionalities, right? Now, part two involves importing of a geometry that comes from another software altogether. It could be software that would have been existingly used in an industry, or something that of a file that you can receive from your customers or vendors as well. So first of all, let me save this drawing file with the name body, right? So this is the body of the enclosure. Let me just rename it. And here we have an SLD-PRT file, which is essentially a SolidWorks part file that we are going to import inside BricsCAD. So as you can see, I can import a lot of file formats, including CATIA, Creo, Inventor, NX, Solid Edge, SolidWorks, IGS, STEP, etc. So this one I'd be importing a SolidWorks part file, which is about a 2 MB file, which probably the source could be, as I mentioned, it could be from your customers or from your vendors, or could be from the existing design solutions that you'd be using in your organization, right? So as I said, it can work coexistingly with your current software solutions. You don't have to replace everything in particular, but you can use it simultaneously just to reduce down your costs that you'd be incurring on using those softwares full-fledgedly, right? So BricsCAD can do most of these things, and as you can see, right, once it's imported, it's a dumb body. Okay, it has its own component representation, but it acts like a dumb body, right? Although it's a sheet metal body from SolidWorks. With BricsCAD's convert to sheet metal functionality, we can actually then convert it into a BricsCAD sheet metal body, and BricsCAD is able to recognize all of the sheet metal features that probably would have had it, in this particular body. So it could be the flanges, the reliefs that we have, also the form features that might have got inserted, the hole features that might have got inserted, etc. So now it's created, it's converted into a BricsCAD sheet metal body, and it's not just for the sake of it, right? We can do a lot more on this, apart from creating a drawing or apart from just recognizing it as a sheet metal BricsCAD body. So what else can we do, right? So let us try and replace those form features. One might think that when it comes from another software, it might not be completely parametric, and of course that's true. So in case of this form features, let's say if we want to change the length of the louvers that are there in place, all I need to do is simply replace the louvers that have come from SolidWorks. Very smartly, I can replace this. All the louvers, BricsCAD is able to recognize all the similar form features. So it's another smart feature within the sheet metal environment. And it will replace all those louvers that you can see on the screen right now with the BricsCAD louvers that I have. So BricsCAD is able to create form features as well, as you can see. But now I don't want to create something from scratch. I want to replace the existing form features with BricsCAD's form features, which I have been able to do it. Now, the advantage of replacing the form features that came from SolidWorks with BricsCAD's form features is I get those form features as parametric form features. Now, if I want to change the length of all the form features in one go, all I need to do is simply select all those 48 louvers, go to the parameters, and let's say if I want to change the length from 35 to 38, okay, I hit enter. It will take some time for it to calculate and process, but just if you just pay attention on the screen, you'll see a change in the length of these louvers that are there, right? It might just flash in a fraction of a second. So if you just pay attention to the screen, we'll say the change. Just wait for it to happen. Yeah, there's it. There it is, right? So that's how I'm able to replace the existing form features that could have come from any of the 3D modeling software. And then finally, of course, the most important thing is whether we are able to unfold this entire body. Yes. So we can do it. We can unfold this body completely. And the representations are as per design standards that are used in any of the companies. So let's say even for the form features that you can see, those are the very accurate representations that we get for the louvers, for the other form features that are present, right? And I can save this as a DXF like we did for the earlier geometry. And as we can see, we have the bend line annotations, the angle of the bend, the radius of the bend, the form features in place. Of course, there'd be need to manually dimension it a bit, but then we get the exterior dimensions. So we come to know how much of a material or what length of the material, what area of the material we'd need to create this kind of geometry, right? So that is something that we have in place with BricsCAD. The exterior dimensions are there in place already. So this finishes our body part, right, wherein we saw how we can leverage BricsCAD's interoperability with other softwares to be able to recognize it as a sheet metal body and then can use it further. Okay, so that creates the that completes the modeling part. And now we'll see how we can assemble inside BricsCAD. Okay, so assembly is extremely simple. With the type of constraints that we have, it's something that each and every user who has come from the engineering background would be able to understand. It's as simple as that. So all I'm doing is I'm just importing or inserting the door. It's not an import, I'm sorry. It's inserting the component and I'm creating an assembly. So we'll insert this door which we previously created. And I'll just change the representation to modeling. Okay, and then I have some additional components in place which I'll insert. Okay, and in BricsCAD, since it does not differentiate between a part and an assembly through an extension, they are all DWGs. I can simply insert a component using the BM insert command, and this is the one that I want to insert. So this hinges would essentially be on the door, and then we have a separate hinge for the body as well, which will mate together to create our complete enclosure body. Right. So we add two instances of it. There are two hinges. And we'll see how we can use BricsCAD's constraints, the 3D constraints, for us to be able to position it on its actual place, right? So we need to be able to constrain it on the side of the door. First of all, we'll make it constraint ready so that, for the software, it really becomes easier when we apply constraints to move or rotate the body. So I'm selecting this face and I'm using a coincident constraint, which will make these planes coincident with one another. I can use the same constraint once again for the top face of the hinge and the top face of the or the bottom face of the door body where this hinge is going to be placed, right? So that constrains it completely in terms of the position that I want to place my hinge in, right? So I can just move it across, and now it's freely movable across the y-axis. And what I can do is now give it a distance constraint from the outside side of the door to the flank or to the hinge at a distance of 200 or 201, because we need some clearance when it'll get mated with the hinges present on the body, right? So I'll just make this also constraint ready, just rotating it with the help of manipulator. So the gizmo that you see on the screen right now, which I'm using to rotate the components, is actually called as the manipulator in BricsCAD, which kind of helps us easily maneuver the components by translating it, rotating it, or even create copies of it. So it's a real handy tool which I can make use of, and I need not use any commands as such for me to be able to carry out those operations, right? I can use it for 2D entities, for 3D entities as well. So I'll just constrain it once again. It's the same type of constraints that I've given for this particular body as well. I just translate it a bit further down and then apply the distance constraint for this at a distance of 201. All right. Now with this, we have completed the placement of the hinges. And then we'll try to add more components, like I was mentioning earlier, the switches for our door and also the lock. Okay. So again, we'll use the insert component, or you can even type in BM insert on the command line, which essentially executes the same command. You can go in from the ribbon or you can use it from the command line depending upon the comfortability level of the user. So essentially, it really becomes handy for someone who's coming from a CAD background, who's very used using the command line and very comfortable using the command line rather than using the ribbons. Right? So it's really handy for them for them to be able to execute the commands that they want through the command line, even for the 3D operations that they do. So I'm inserting 4 instances. You can simply copy as well using the gizmo, or just do a copy paste as well. That should work. But that's the process that I'm comfortable with through insert component, and I can very easily insert it. So this particular constraint would help us align the switches to this particular hole, right? So we have this concentric constraint and it's got aligned, as you can see, and I'll apply a coincident constraint for it to be able to fix the geometry on top of the surface that I have. So this Now I'll just select the top surface so that it's coincident on the top surface, and I'm able to place my switch. Similarly, I'll apply the same constraints, same set of constraints to the other geometries. One thing that I can do is copy the same switch that I had constrained earlier. Just copy it and place it onto the next whole representation. That would have done things for me. But then this is how I can make sure that the constraints that I've applied are kind of perfect. And then in case if I want to change the constraints, in the near future, or if the whole geometry shifts, the entire geometry along with the switches needs to shift as well. So if there's a change in the design principles, let's say if the hole has to shift by a distance of another 10 mm or so, all I need to do is just shift the hole by another distance of 10 mm, and the entire geometry would update automatically, right? So instead of copying it at that particular place, constraining the geometry is really handy. And as you can see, it's really very simple in terms of how to apply constraints, coincident, concentric, distance, and there are other constraints as well, which helps us, complete our assembly modeling. The last part for this one would be the lock. I'll just place it over here, make it, let's say, constraint ready. Probably just rotate it, or I can directly apply the constraints as well. So just concentrate for this one and for this one. Right? And there's this, okay, now it's got a bit inverted. So I can just shift it upwards. We need the handle to be there on the outside. So I can, let me see if I can use the gizmo to rotate it. So that would be this particular axis of rotation. Oh no. So since I've constrained it, and now I'll not be able to rotate it. But what I can do is the concentric that I've applied, the concentric constraint that I've applied. So in case if I want to change the directions right now are same. I can simply say it opposite and it just invert itself. So instead of rotating it that way, manually, since I already applied the constraints, and rather deleting it, I can simply change the directions in which the constraints have been applied, right? So this helps me create the door lock, and that kind of completes my entire assembly of the door, right? Again, this is not the complete assembly or the main assembly. This is just the sub assembly that would get inserted in another main assembly, right? So this is the process that we are following. We had the parts created, we brought in parts from another software, and then we inserted components. We have the sub assembly, and then we'll use this entire sub assembly to create the main assembly. Right, so we'll store it in the subassembly folder. Let's name it something like door subassembly, which would help us recognize that, okay, this is a subassembly including multiple components within it. Let's close this. Okay, so a new drawing once again. Now this would be the final assembly that we have. We'll insert the component, the body first, because that forms the base for our main assembly. The door would be placed on top of this. So let's place our body and let's fix it so that this does not move and this acts as a rigid constraint. So we'll just make it rigid so that the body does not move as and when we are applying the constraints on top of the other parts after inserting the components. Right? So let us constrain this fixed and insert. So this is the main assembly, and over here inside the main assembly as well, we can insert components. So it need not be in a particular order like we saw with the door, right? That we need to create the subassembly first, and then and only then we'll be able to create the final assembly. It's not like that. This components, when we insert, it be specific to this particular file. So any change across these hinges would be reflected in the main assembly file. Okay, that is how it works. Any change in the hinge 2 that we had in the door would be reflected in the subassembly as well as the main assembly. Okay, so it's cascading down, right? Let's say if there's a change in the child file, all the parent file would accommodate those changes to those parts as well. Okay, so here's where are we applying constraints to these hinges. Again, Very simple, very plain and simple, just applying coincident constraints so that it stays in place. And once I've applied the coincident constraint, all I need to do is give them the distance constraint from the faces. Right? I'll just apply the same thing over here as well. First, coincident constraint to this face. And as you can see, right, this is a geometry from, again, I'm reiterating this because this is the interoperability feature of BricsCAD. Sorry for that. Just selected the wrong component. Just select it once again. So this is the interoperability feature of BricsCAD, wherein I'm not just able to constrain geometries within BricsCAD that's been modeled inside BricsCAD. I'm also able to constrain the geometries that are outside or modeled outside of the software environment, right? So here's, I'm able to constrain this. And then all I need to do is give the design distance constraint so that it stays in place. So this would be in reference to the constraints that we had placed for the hinge in the door. Okay, so the hinges would be placed in between. That's the male female joint, right? So this would be at a distance of 200 so that it doesn't interfere with the hinges that we have in place at the door. And this again would be at a distance of 200 from this particular face. Let me just move it a bit on the right hand side. So just moving it. This is a free movement. Gizmo kind of helps us, or the manipulator sort of helps us to determine which degrees of freedom are free and which could be the ones that are locked. So essentially, if it rotates in one particular axis or translates in one particular axis, then we kind of know that, okay, these are the degrees of freedom that are free for that particular component, right? So that is how we can kind of check the free degrees of freedom, and if needed, can be constrained at a later stage using the constraints. So let me insert the door geometry, the sub-assembly that we had created. So while inserting, as I said, we can make it assembly ready or constraint ready. So I'll just flip this entire thing top to bottom, right? And also rotate this so that the door is placed correctly. By 180 degrees is what I'm trying to rotate this. Now I have the accurate representation of the door geometry, and the hinges are linearly placed as well, right? So for me now it really becomes easy to apply the constraints. Had it been placed vice versa or in the opposite direction, it could have still worked, but then it's a bit of a difficult thing for the software as well to understand how the geometry needs to rotate or what the design intent is. So it's better we keep it constraint ready so that it kind of helps us to constrain it very easily. So it's just two constraints that I've applied, and my entire geometry is now constrained. So this completes the assembly, wherein we have seen a lot of things. Now we'd also see what kind of degrees of freedom that are open, right? So for this door, they should be able to open or rotate, right? As you can see now, when I'm opening this door, the body also translates onto a different axis. So we'll fix the body, right? Because it's translating in the x-axis, we'll fix one of or both of these faces once again, so that now when I'm trying to rotate the door across the hinges, across this particular axis, okay, now it's steady. So now I can see the body does not translate as in when I'm trying to rotate the door, and it's perfectly mated. So this now completes our assembly. Also, if I show you the 2D representation, the way the hinges have been placed, these are all perfect because we had our design intent in mind and the positions that we wanted to have for those particular hinges, right? And then last but not the least, of course, comes the annotation part. So let me just save this first. And we'll go to annotate to create accurate representations, 2D representations of the assembly that we have. So let me just delete this first, delete this viewport. And the best thing about BricsCAD is, if you can see, this entire thing looks like as if I'm working in a CAD environment. So, and majority of us, or 99% of the users that would be working in 3D or 2D CAD environments are well known to this particular interface, right? They need no introduction to this interface, and hence it really becomes easy for them to adapt if they're coming from a 2D environment or a 3D environment doesn't really matter, because everyone knows what this environment is. So we have the model layout space wherein we used the base view feature of BricsCAD for creating this accurate representations of drawings, and these drawings are all associative. So we have had a lot of seminars or webinars in the past wherein we have explained this particular feature of BricsCAD, where you change the 3D model and the entire 2D drawings get updated. So any change in the 3D model whatsoever would update the 2D drawing representations inside BricsCAD. Okay, so, and again, these are all in DWG, right? So the 2D representations that we have created is in DWG. The 3D models that we have created are in DWG. How does that help? The transition that happens from 3D to 2D, or even from 2D to 3D, is seamless, right? So let's say if I want to annotate certain, or rather, let's create sections first. So I'm creating a section on the side view placement, a horizontal section as well as a vertical section, and we'll see how the section behaves, right? We can enable a lot of other geometries as well, how the hidden lines are going to be visible, how the tangent lines are going to be visible. So the user has all the control over all these parameters from a properties task. We can even change the type of views or projections that we need to use, if it's a third angle projection or the first angle projection that we need to use inside our drawing. So let me just make this in line with the view that I've placed. Okay, and in case if I want a bigger paper size, all I need to do is go to page setup and choose a different paper size which is larger than this. Okay, so that is something that I can do. I did it initially from A4 to A3, but you can do it from A3 to A2 or A0 or A1, depending upon the type of components or the sizes that you'd be working on, and also the scales that you'd be working on. So this could be easily scaled down or scaled up, or I can even use the true scale if needed, depending on what kind of plots that you use for your companies and standards. This is the section view, a full section view. I can have a half section view or section view at a certain depth, right? As you can see on the right hand side on the properties, when I do the section, it does ask me for the depth of the section as well. And I can easily manage the depth in case if I do not want a full depth section, I want it at a certain depth, I can do that as well, right? Now, of course, the annotations, again, are associated with whatever changes that we make. We can also create the BOM, the bill of material. So this is the advanced bill of material manager within BricsCAD. We can very easily manage the entire bill of material. For now, I'll just be showcasing how easily we can place, and it again is able to detect the body that was kind of created in other environment. It's been able to detect that the hinges that we place, the locks that we have in place, the switches that we have in place, and rest of the other properties, if needed, can be added as well onto another column through the advanced bill of material manager in BricsCAD. Right. Last but not the least comes the dimensions. So let's say if we need to add dimensions, we can simply use the annotations and BricsCAD, very accurate dimension representation. And the best part is, if we dimension this over here in layouts, and what I have personally seen happening is, we annotate the entire thing in a 3D MCAD tool, and when we bring it inside a CAD environment, let's say it could be something like AutoCAD or even BricsCAD for that matter, when it comes from a traditional 3D CAD environment, it kind of loses all its intelligence, right? The dimensions act like lines, arrows, and text. It all comes exploded. Okay, there is no intelligence whatsoever associated to the annotations that we place inside a 3D modeling environment when it comes to the 2D environment, right? But with BricsCAD, since it's all in DWG, right now, let's say if I just want to share this 2D DWG with my vendor or the production team, all I need to do is just export this as a DWG. Okay, I can go to my let's say layout and then simply right click and export it as this DWG. Let me export this. Say export to DWG is the standard file format that we can export our layouts in. Create a new folder. 2D extraction and just save this. Right, and once we do this, we can simply open it and just see that the intelligence is still there. A table remains a table, a dimension remains a dimension, right? All the layers have been brought in as well. So let's say if I want to dimension or redimension it, it kind of uh, has the intelligence still within the drawings even after we export it in a 2D CAD environment. We want to change the layer of the layer color of the hatches that we have in place, you can simply do that as well, very easily. So when it comes to the beautification part, or rather the annotation part, right? Wherein the general workflows is you create the entire model in a 3D environment and then shift it to a 2D CAD environment for the user to be able to do a quick annotation on top of it. What happens is, since it does lose a lot of intelligence, it kind of BricsCAD makes sense because then it does not lose any sort of intelligence or associated on these entities, right? And then it could be very easily managed once it comes to the 2D environment as well. So this kind of covers the entire demonstration for what we can do with sheet metal in BricsCAD. Of course, we covered a lot of topics, including how we can start from scratch, how we can import a 3D model from a different environment, convert it back into sheet metal, recognize the features, replace some of the form features to make it parametric, create design views, create unfolding views, and then finally create an assembly for us to be able to complete our modeling, and then the drafting, which is kind of associated to the models that we have in place. Right? So that was in terms of the demonstration that I had to do to showcase the sheet metal capabilities of BricsCAD. More or less, whatever you can do in your current 3D CAD environment can be done through BricsCAD, or it can work in conjunction with your current existing workflows that you have in place. So that this is where we become quite a bit of cost saving solution offering in the market because of the licensing options that we have in place. So we have three type of licensing policies: single, volume, or network, depending upon the your requirements as such. Again, these licenses are all perpetual in nature with maintenance associated to it, so that you can get the support from the OEM and also the latest updates and upgrades that we have in place when you're on the maintenance. We do not have any named users as such because the licenses are linked to the company and not the individual user. We have software in multi languages and you can use and use anywhere across the globe. All subscriptions that is kind of rent, the software for a limited amount of time. You can avail the subscription benefit as well. But at the same time, let me just say, titles are perpetual in nature, including Light, Pro, Mechanical, BIM, and the ultimate offerings that we have. In terms of the last representations for Bricsys, how we are different and what we can do to help you out with your design challenges is something that I wanted to outline. So firstly is the accessibility aspect. As I was mentioning, the entire design technology that can really offer manufacturer improvements in terms of efficiency, flexibility, and innovation is costly, complex, and provides much more than is realistically needed. So all your 3D environments, though, may be really, really efficient in terms of giving you all sets of features. But the question is, do you require all those features, right? Do you all use all those features? Is what the question. And then, does it make sense for paying up for the features that you don't need or you might not use? Okay, and does so technically again, the next question could be: does BricsCAD solve your requirements? And if yes, what's stopping you from moving towards the solution offerings that we have? Because traditionally, if something meets your requirements, then there should not be any hesitation whatsoever in moving towards a software that can save a lot of your costs for your organization, right? Uh, so again, low cost of ownerships, low cost of entries. Again, in terms of the trainings that you need to enable your users, or in fact, downtime that you need for your traditional 2D CAD users to shift to 3D, or even for your existing 3D users to shift to a new environment, it's really less. You can simply go ahead with a day's training or probably a day's overview of BricsCAD, and then is as easy as it goes. You can simply start modeling out of the software. Plus the additional benefits that comes along in terms of having everything in DWG, right? So that is something that we saw, wherein we can make the models backwards compatible, which is not quite the case when it comes to a traditional MCAD tool. So when I speak about a traditional MCAD tool, it could be something like SolidWorks or Inventor or PTCTO or even anything else for that matter, which do not allow any sort of backwards compatibility whatsoever. In terms of learning, yes, it's fairly simple to learn because anyone and everyone who knows CAD or 2D CAD can really get accustomed to BricsCAD, even its 3D modeling capabilities to that extent. Right? So these are some of the customer references that are using BricsCAD in manufacturing. We have some well-known names like Mazda, Hitachi, and then there are a lot of other companies who do use BricsCAD. Of course, there are a lot of different disciplines of engineering that we serve in. So we basically, have solutions for interiors, industrial equipment, scaffolding, structural engineering, so on and so forth, catering to each and every requirement of these particular disciplines. But then again, if at all, when it comes to manufacturing, then yes, we do have capabilities that can kind of match to the capabilities of the existing 3D environment that would be using. Right? Just one of the case customer story that I to showcase, that is from Mazda, which is one of our early users of BricsCAD. They adopted BricsCAD really early, and these are some of the words from Mr. Shinya Kohama, who's from the production planning department at Mazda, and they have been still using BricsCAD. It's really nice to know that one of the most prominent name in the market today is using BricsCAD. They are using BricsCAD Pro, of course, with its 3D modeling capabilities as well. So BricsCAD Pro does have certain 3D modeling capabilities. The sheet metal module is involved or is available in BricsCAD environment. Right now, that is where my presentation ends. I think we are bang on time, and extremely apologize once again for that we and I really hope the session was informative. And in case if there are any queries or questions, please feel free to email it to us or put it in the chat box. Happy to answer those questions for you. And at the same time, please feel free to use our 30-day trial, which is available at bricsys.com. In case if you do find any differing yourself or creating an account or anything else for that matter, feel free to reach out to us. We'd be more than happy to help you out. So thanks once again for attending this session. Thank you for your time. I hope it was informative for you, and many more such sessions ahead. Thanks once again.